behind Cali scores. Hello, people in the chat. I know we're live now. So, Cali scores are ranked 1, 2, 3, 4. And you've probably seen maps with like the colors of like green, yellow, orange, and red. No? Okay, maybe, okay. Every week they come out with a new report indicating what, in New Jersey, what the Cali score is. Cali is like COVID awareness level, blah, 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 whatever. So we shut down in the spring when our Cali score actually was in the red. It was the level 4. If it's at level 4, according to the state procedures, if we get to level 4, then we have to go into, or the county, I should say, would have to go into virtual learning, no matter what. Right now, currently, all of New Jersey, every single county is in level 3. Level 3 is the various precautions that are put into place. And then, of course, you do have the option to go virtual, but it's not required. Now, how does one get a Cali score of 4? Well, there are 3 categories. And I want you to really think about this because there's something a little bit messed up with the way that they calculate it. There are 3 categories, and each category is measured either 1, 2, 3, or 4. If the average of all 3 categories is a 4, then our Cali score is a 4. But it depends on whether or not it rounds up or down. Now, currently, the 3 categories are cases per 100,000 people, which right now, New Jersey, I don't know if you heard, we just broke another record the other day, 6,000 cases in a day. Nobody? Somebody? The second category, which, by the way, for that category, we're totally a 4. We're totally a 4 for that category. Then for the second category, it's actually something called CLI percent or CLI rate. CLI is COVID-like illness, meaning you went to the doctor, you found out that you did not have COVID, but you were experiencing COVID-like symptoms. It is a very subjective standard because the doctor not only has to identify your symptoms as being COVID-like, but they also have to report it under that category heading. It's kind of messed up. Currently, New Jersey is at a 3 for that category. Then the 4th category is positivity rate, meaning you go in, you get tested, you're either positive or you're negative. Positivity rate right now, currently, according to the report that came out last week, New Jersey is at a 2. 4, 3, and 2 average to our score of 3. So we have a Cali score of 3, meaning on the map, we are colored orange. There are precautions that are put into place, but we are not required to go virtual. Good for us. Now, there's a new report that's going to be coming out this week, and the theory is that the 3rd category would jump up a little bit. So our scores would be 4, 3, and 3, which average to a 3.3. 3.3 rounds down. So our Cali score would remain a 3. In order to have a Cali score of 4, either all 4 categories have to be 4, or all 3 categories have to be 4, or it has to be 2 4s and a 3. And it would be round up. So right now, we're at a 3.3, which rounds down. If we were at a 3.6, it would round up. It seems very arbitrary to think that 0.3 separates us from being here today and being fully virtual until that Cali score comes back down. Fun stuff. It's not our choice. Or I'm sorry, let me rephrase. It's not our choice. It's up to the individual school district or the county to make that call, or the state. But the state is not going to make that call until we get a Cali score of 4. So that's where we're at. You guys should know your numbers. Just saying. It's important to be informed about this kind of stuff because a lot of people tend to throw out their opinions, but there is an actual metric standard by which they measure these things. And I want you to be aware of that. Yay. So here we are. We're back in class. Now, showing you this calendar up here. I have you this week. I have you next week. this week right here, don't draw on those. People got to live in them. During this week, you're taking benchmarks. I know, right? Yay, benchmarks. Yay. Woo. Everyone's excited. Yay. I know my supervisor's excited. Look at my excitement. Can you tell? Yeah. And one of them actually was a mistake. Remember? I told you about that. Anyway. Yeah, that's where we're at. Now, last week, as you so all graciously saw during my live streams, I said that this week I would be assigning you a major assessment in regards to the chapter that we have been covering. And yes, I am still planning on doing that. I'm going to be assigning that major assessment somewhere around midweek, probably around Wednesday afternoon or Tuesday afternoon, something along those lines. I haven't decided yet, but it will be assigned this week. I want you to be aware, major assessment coming up. That is what we're going to be focusing on today. Our goal is to review some information that I have prepared as I've done last week. For the sake of argument, in terms of my own opinion with the whole shutdown and stuff, you guys saw my live streams, obviously here, and you saw my live streams when I did them at home, right? Now, I don't care about where you are. In the past 2 weeks, which live stream do you think was more effective? The one that I did here or the one I did at home? Why? Yeah, a lot better. Not everyone has that setup. I was actually using 2 cameras, which I thought was awesome. I don't know. Be jealous of my 2 camera setup. And I could do transitions between things. It was so great. It was so great. But that's where we're at. In order to get this thing started, ladies and gentlemen, I'm going to need those notebooks out and open. I have a big problem that I want to try with you. Now, this problem is going to take some time. So I want to introduce this problem, and then I want to break it down piece by piece with you. Let me close these windows. There we go. Close these windows. Open up this window. Chapow. A zoom. Okay. Now, you don't have to worry about copying this problem down, obviously, because there are a lot of words. But with this particular problem, you can begin jotting down some important information that may be helpful. But let me kind of read this to you, and we'll see where it's going to lead us. A tool shop is hired to make a metal mold in which plastic is injected to make a solid block. See the diagram below. Now, in this diagram below, it's a little weird to see, but there is a solid lined 3D block and a dotted lined 3D block on the inside. Now, the solid line on the outside, that is made of metal. And there's a little hole. And that's where they inject the plastic. Now, in there, you pour the plastic in, everything hardens up, you open up the metal mold, you take out the plastic block. Yay, we did it. The finished plastic block, which is the dotted line, should have a length that is 8 inches longer than the height. It should also have a width that is 2 inches shorter than the height. Each plastic block, again talking about the inner plastic block, requires 96 cubic inches of plastic. That is volume. That is a plastic block inside of a metal mold. If the sides of the mold are to be a 1/2 inch thick. How much metal is required to make the mold? Now, this is the exact type of problem that we have been preparing for. This is the exact type of problem that is going to utilize a lot of the skills that we've been learning over the past few weeks in solving polynomial problems to get done correctly. This is an amazing problem. Now, obviously, there's a lot of stuff that we could potentially jot down. Agree or disagree? If you had to list a top 5 list of your most hated things about math, would you guys have word problems in that top 5? Many of you are nodding yes. When you see a word problem, do you tend to just kind of skim it for the numbers and hope for the best? It happens. I know exactly what's going through your minds. I know exactly what's going on with word problems are the scourge of every high school math student. They just wish they would go away and die. Gosh, it's a word problem. What is it even asking me to do? Well, let's just try to take it a step at a time. Instead of worrying about what it's asking me to do, let's just take it a step at a time, and let's try to organize this information. So, I'm going to go to my notes real quick. I'm going to write down some information. Today is the 7th, 12/11/20. This is polynomial word problems. Now, this problem is going to take some finessing. This is a problem that they would put on a state test. This is a problem that you may see on a final exam. This is a problem that they would put on an open-ended version of a national test. It's a great problem. So let's talk about first the plastic block. And to the best of your ability, draw a little 3D rectangular prism like that. So we have a little plastic block here. A tool shop is hired to make a metal mold in which plastic will be injected to make this block that we just drew. The finished plastic block should have a length that is 8 inches longer than the height. Look what I'm writing down here. I'm going to read that sentence again, along with what I just put on this block. The finished plastic block should have a length that is 8 inches longer than the height. Since I don't know what the height is, I'm going to label the height as x, and the length clearly is 8x plus 8 because of that sentence. It should also have a width that is 2 inches shorter than the height. Meaning that's the width that I'm going to put on it, x minus 2. And each plastic block, again, every sentence that I've just said so far is about the plastic block. Each plastic block requires 96 cubic inches of plastic. Now, the next sentence talks about the mold, the metal mold, but I'm going to leave that alone for a moment. I'm not going to touch that for a moment. I want to talk about this plastic block. The ultimate question is asking about the metal mold. But I'm going to ignore that temporarily and look at the information that they've given me so far. They've given me 3 dimensions on a rectangular prism. And they've told me, now mind you, they didn't say the word volume. They did not use the word volume. but the problem said that the plastic block would take 96 cubic inches. Cubic inches, or inches cubed, is a measure of volume. Not area, not length, but volume. How does one determine the volume of a rectangular prism? Or better yet, the volume of a cube? Not to bring up your PTSD in geometry. How does one find the volume of a rectangular prism? Ooh. When I said geometry, did y'all get a tingle down your spine? Maybe. I don't know. Some people do. Did you guys do 3D shapes in geometry? Say again? Sadly. Okay. Sadly. Was that the question? Was it during the time that you guys were in class or with the time you were at home? It's kind of rough. I don't know. Well, how about this? How does one find the area of just a rectangle? Length times width. That's just the area of a rectangle. The area. Now, mind you, the area, the two-dimensional area of a rectangle is length times width. How do you find the three-dimensional volume? Yeah, length times width times height. It doesn't have to be sad. It could just be one of those things where it's like, I kind of remember something. Okay. Now, this is not going to answer the final question just yet, but I need the following information. Length times width times height should give me 96 cubic inches in volume. Length times width times height should give me 96 cubic inches in volume. Okay. I'm going to need to multiply this junk out. Because being that we are dealing with a chapter on polynomials, I am going to have to multiply this out in order to get said polynomial. Now, if you notice, I'm taking my time. I'm taking my time on this problem. Obviously, a problem like this is not expected. You're not expected to do this problem like over the course of an hour and a half or some junk like that. But I'm taking my time on this problem so that we can understand it a little bit better. I got to multiply this junk out. So first, I am going to distribute. The x at the beginning of the problem because I can just distribute it like that. And then I am going to, and again, you could use FOIL if you want to. FOIL is perfectly acceptable as well to use on a problem like this. But I am going to have to multiply out this junk. First add, enter, last. You could do that. But again, I'm going to use a box. I got an x cubed. I got a negative 2x squared. I got an 8x squared. I get a negative 16x. All right. See where this takes me. I end up with x cubed. Separate this. X cubed plus 6x squared minus 16x equals 96. I had to combine those like terms of 8x squared and negative 2x squared in order to get this thing done properly. All right. We're kind of on our way. We are kind of on our way here. We were able to take the information about the plastic block, length times width times height, multiply that junk together, and we kind of got a polynomial. What do I do now? Ugh. You absolutely have to. Let me emphasize that point. The goal is you're trying to find out right now the dimensions of the plastic block. You're trying to find out the value of x. But you can't do any of that until you get one side equal to 0. you got to get one side equal to 0, as we talked about last week. This is where we're at. So now, this polynomial, this crazy, wacky polynomial, this is where we've been basically for the past 2 weeks. We have been graphing these things. We have been describing the end behavior of these things. We've been determining the attributes of these things. We have been dividing these things. We have been solving these things. We have been doing a lot with polynomials over the past many weeks. What do we do now? I have a polynomial. I got to solve it. What must I do now? Maybe. I could graph it. I could. Now, the thing is, I'm not going to spend too much time worrying about how to graph it because the problem's not asking me to. But what do you mean by graph it? Let's do it. Let's do it. Let's just see what it looks like. Now, you could do Desmos. You could do your graphing calculators that are on your computers. If you had an actual graphing calculator, you could do something like that. I'm going to go to actual Desmos. I'm going to go f of x equals x to the third plus 6x squared minus 16x minus 96. Now, this is interesting. I don't know what this thing really looks like because it's so like out there. Like this part's a little bit up here. I can figure that out. But then this part's like, whoa, how far down does that go? I don't know. I don't care. You said the x-intercepts. Yeah, that's all that I'm interested in. I would be interested in where are the x-intercepts. This problem didn't ask you to graph it. It didn't. So you don't have to worry about fully graphing it. This problem didn't ask about end behavior, so you don't have to worry about end behavior. But knowing what the value of x is vital. Looks like positive 4. Looks like negative 4. Looks like negative 6. Let's do it. I have those 3. Let's just see what happens. Suggestions, where do we start? Which one do we start with? Pick one. 4, negative 6. Which one do you want to start with? Start with 4. Okay. Now, the whole idea of synthetic is we are going to try and prove that we have all the zeros of that polynomial. 1, 6, negative 16, negative 96. All right. And you said 4. I already forgot what you had said up to that point. 1 plus nothing is 1. Multiply, add, multiply. Oh, I get it. Add, what is that? 24. Multiply. Just going to double check real quick in my calculator. 24 times 4. Oh, look at that. It's 96 right on the dot. It's 96 right on the dot. Nice. Okay. So where do I go from here? All right. Well, let's figure out the other zeros then. Let's make sure the other zeros actually do work the way that we think they do. Remember, remainder constant x squared. I'm going to do another synthetic because, well, I believe we have the other zeros. Negative 4. Let's try negative 4. 1, multiply, add, multiply, add. Nailed it. We believe we know the remaining 0. We believe it's a negative 6. At this point, it's pretty obvious that it's a negative 6 because the remaining factor that we have is x plus 6. So it should be negative 6. But if you decided that you wanted to just keep going with synthetic to see what the heck happened, you could do this and actually just prove it, but that's not necessary. Let's see what we proved. We have proved 4, -4, and 6 are zeros of the function. Now I'm going to ask you an important question. I'm going to ask you a very, very important question. 4, -4, and I'm sorry, that should be a -6. Change it to a -6. I wrote +6 for some reason. Boom! Now it's a -6. I just fixed it. But 4, -4, and -6 are the zeros of the function. Only one of them is the number that I'm looking for. Only one of them is well, not the answer, but the number that I'm looking for. Which of those 3 numbers?
4.
Why? I need more context.
Well, right now we're trying to figure out the volume of
The plastic block.
or whatever it is. And you can't really
So technically, we've solved for the zeros of the function. We solved for, as you said earlier, the x-intercepts. We've solved for the x-intercepts. Look at this first page. We have solved for x. I agree with you, it should be +4. And it is +4. It's not just because it's positive. It's not just because it's positive. It's because 4 is the only value of x that you could plug in to this rectangular prism and it make sense. It's the only number that you can plug in to this rectangular prism and it makes sense that these are actually the length, width, and height of the rectangular block that you have. So, let's see here. Where'd that marker go? There it is. The conclusion, oh, it's frozen, like my heart. There we go. The conclusion that I'm going to come to is this. X equals 4. So, dimensions of block are, and I'm going to draw a little rectangular block right here. And because it's 4, I'm going to say, well, the height has to be 4. The width has to be 2. And the length has to be 12. Yes. That is the plastic block. You do it real quick. What's 4 times 2 times 12? What's 4 times 2 times 12? 96, right on the dot. Cool. Mr. Markey, we did it. We solved the problem. No, we haven't. You haven't solved the problem yet. I'm going to put the word problem back up in a moment. But we have gotten a lot of information. We have. But we have not solved the problem yet. To which a lot of you are thinking, Mr. Markey, this is why I hate word problems. I know. I'll tell you a secret, though. This is why I love word problems. Because you never quite know when they're done. Let me go back to the problem itself. Let me zoom in on this question. Because we have a bunch of information so far. I'll focus that. Come on, there we go. Move it up a little. Too far. There we go. So let's see what this problem is. A tool shop is hired to make a metal mold in which the plastic is injected to make a solid block. Cool. The finished plastic block. Okay, hold on. The finished plastic block. The finished plastic block, which is on the inside of this thing, has a height of 4, a width of 2, and a length of 12. Cool, I got that. Each block requires 96 cubic inches of plastic. Yes, got it. because you did the multiplication, 96. They multiplied to 96. That's 96 cubic inches of plastic. Yes. If the sides of the mold, when I'm talking about the mold, I'm talking about not the plastic. I'm talking about the metal mold. If the sides of the mold are to be 1/2 inch thick, how much metal is required to make the mold? Ooh, interesting. The metal mold is going around our plastic block. What do you mean dilate? Dilated means something entirely different in geometry. I'm going to say your mind is in the right place. Your mind is definitely in the right place. The beginning portion of what you explained needs a little tweaking. Just a little tweaking. But yes, there will be a subtraction taking place. There absolutely will be. So let me draw this, and you guys are going to put this into your notes. So we have the plastic, in fact, it's about plastic block, which I've drawn multiple times now. I'm just going to draw it again for funsies. 4, 2, 12. And now we have the metal mold, which the metal mold is what is surrounding the plastic block. It's the outside. It's what you're injecting the plastic into in order to make the plastic block. The walls of this metal mold, the walls. How many walls are on this mold? How many sides are there on this shape? There's 6 sides. 1/2 an inch thick on every side. Which, if it's 1/2 inch thick on every side, what is the height of this metal mold? If it's 1/2 inch thick on every side, what is the height of this metal mold? It's going to be 5. Because 1/2 inch on the bottom, 1/2 inch on the top. It's going to be 5. The height of that metal mold is going to be 5. What about the length? 13. Because the length, the left side and the right side would be 1/2 inch thick each, with that plastic being on the inside. And then logically, this dictates that the width should be 3. Oh, crap. We're almost there. Almost there. That's the dimensions of the metal mold. Now, hold on. Just for the sake of argument, the volume is 195. That's volume. But now he had a very interesting point about subtraction. Because the metal mold is hollow. It's hollow. The metal mold has nothing on the inside until you inject the plastic into it. The metal mold has 1/2 inch thick walls, yes, but the inside should be filled with plastic or whatever liquid plastic before it solidifies. The volume over here we said was 96. And what was the suggestion you made? Could we do with those numbers? Subtract them. If you take 195 minus 96, you get 99 cubic inches. 99 cubic inches, which is the amount of metal to make mold. This is an amazing problem. This problem is so multi-layered. It starts off in such a way where they're talking about just this concept that people can visualize. The idea of like a metal mold and injecting stuff on the inside. Okay, I guess I can kind of follow that. Then they start talking about certain dimensions, and that's guarantee you that's where people got a little, scared, to say the least. Let me walk you through what a student does. Let me walk you through exactly what a student does with this problem. Oh no, it fell. A student reads this problem like this. Okay, a tool shop is hired to make a metal mold in which plastic is injected to make a solid block. Oh my God, I don't want to keep reading this. They haven't even gotten to numbers yet. Okay, maybe they start thinking about, okay, the general concept of like what a mold looks like, and okay, you're injecting stuff in the, okay, I maybe see the diagram below. Okay, the finished plastic block should have a length that is 8. Oh my gosh, what do I do? What do I do? And then they panic, and then they cry, and then they jot down some numbers, and then they try multiplying 8 times 2, and then I don't know, they don't even know what to do with the half-inch thick thing. More than half the students leave the problem blank. Don't lie, you've done it. Leaving the problem blank. But I'm telling you guys, with some finesse, with some pushing, you can get this thing done. You absolutely can. It's a fun problem. Okay. Next problem I want to do. I have a problem that I have on my jump drive that I would like to do with you. I just have to find said problem. Now, this problem is going to be an all-inclusive graphing problem. Now, what's going to happen is this. I am going to get you started. I am going to get you started on this problem. But then you are going to finish this problem. Now, all that being said, obviously you had a homework due for me. When was that homework due for me, by the way? Yeah, it was due last week. Not the reason why I say that is not everyone has turned it in. That's the reason why I say that. But you had a homework due for me on graphing. So I want to make sure that we do finish out what we need to do with this problem. Let's see here. I believe this is the one I want. Yep, there it is. Okay. Where's my paper? This is the one that I want. Now I'm going to write this one down. I'm going to flip my screen over so that you guys can see exactly what we are dealing with. Just double checking to make sure all the numbers are correct. Flip that thing over. Here it is. Zoom out a little. F of x equals this equation. I want you guys to write that down. This is going to be the focus. I am going to give you an opportunity to practice this particular problem after I get you started on it. You are ultimately going to determine all of the zeros of this function. All of the zeros of this function. Not just the real ones. For the sake of argument, how many zeros, if you included repeats and complex, how many zeros should this function have? He's throwing, I don't know, you're changing the numbers. 5. What were you going to say? 3 or 4. Here's the thing. At most, it would have 5 real. Could have less. But if you include complex numbers and you include repeats, yes, there will be 5, as she said. There will be 5. Now, furthermore, when you ultimately graph this thing, I want to know something. What is the leading coefficient? I know you know it. Go ahead. It's -1. What does that mean for the end behavior? Do you know what it means for the end behavior, though? Check this out. You said it's going to start up and it's going to travel down. It's doing exactly what you said it would do. Yeah. It's doing exactly what you said it would do. Furthermore, can you guys visually see what zeros you might start with? What zeros might you start with? -1 and maybe. Let me walk you guys through something here. Watch this. I'm going to get this started, and then you are going to finish it. I'm going to get this started, and then you are going to finish it. Now, for this problem, visually, it looked like 1 and -1 as the zeros of this function. So I'm going to start with the -1. Notice how I am putting these numbers into the function. Notice how I am putting those numbers into the synthetic division. The leading coefficient. What's that there for? It's for the x to the fourth. The x to the fourth is not in the equation, but you have to account for it. X to the third, x to the second. Logically, then, this would be for the x that is missing, and then the +1. So, here's what I want you to do. You are going to begin working through synthetic division. You are going to whittle down this polynomial. Now, when you begin this synthetic division, you're going to take a 5th degree polynomial, and you're going to turn it into a 4th degree polynomial. You have other zeros that you can potentially do. I'm going to give you guys just the next 5 minutes or so, maybe less, 5 minutes or so. See how far you can go with this problem. You may need to look at the resulting equation, see what happens, but let's just see how far you can go. Go for it. +1 and -1 look like possible zeros of the function. I'll bring up that screen in a moment. I was going to make a quick phone call. Hey, do you need something? Oh, okay. I thought it was the time sensitive or whatever. Okay. All right, bye.
I'm stuck like after I use synthetic division with all the x-intercepts that my friends might have, and then I get left with this and I'm not sure what to do with it.
Nice. There are options. Now, if it were a quadratic, we know what our options are. If it were a quadratic, you could try to factor it. If it was a quadratic, you could do the quad formula, whatever, that stuff. But it's a cubic. there's a key piece of information that I have taught. I have taught it, but I haven't talked about it today. It's a key piece of information that I have taught, but I haven't talked about it today. That's the part that she's stuck on. There is a key piece of information that I have taught, but I haven't talked about it today. That's a cubic. So you see the issue, right? Now, this key piece of information that I'm referring to, you could recognize in two different ways. Let me catch up to where you guys are on the board, and then I'm going to show you those two key pieces of information. Oh, I should bring the microphone over, of course, so people can hear my sultry tones. All right, zoom back out. If you begin the synthetic division, -1, +1, 1, -1, 0, 0, -1, +1, 1, -1, 0. Yay, it worked. It worked exactly the way that we thought it would. Yeah. I'm going to do synthetic division again. By the way, I'm going to save a little space here. I'm not going to use the remainder. I'm just going to do synthetic division with the resulting numbers. I just didn't feel like writing them again. But I'm going to do it with +1. -1, -1, 0, 0, 0, 0, -1, -1, 0. Yeah. And you guys ended up with, now I'm going to do this very carefully, remainder constant x squared, x cubed. This is a negative x cubed minus 1. Here's what I want to show you. Here is what I want to show you. Look at this. Oh, zoom back out. There it goes. Good. In the y equals key, I have this original 5th degree polynomial. And we were able to visibly see -1 and +1 as zeros of the function. Now, as I said, there are two things that could alert you to what to do next. There are two things that could alert you as to what to do next. And well, let's start with one of those things. What's that? Looks like -1. What else is it? It's a turning point. If a turning point occurs on an x-intercept, this is in our notes, or it should be. If a turning point occurs on an x-intercept, that tells us we have repeated zeros. We have a repeated 0. -1 is a repeated 0. Now, Ms. Maranki, how am I supposed to remember all that? Well, I did say there was something else that you could recognize. I did say there was something else. And I'm going to show you exactly what that something else is. Put your eyes on the screen. Let's see what happens next. Check this junk out. Look what I'm doing up here. I'm taking the original polynomial and I'm dividing it by x plus 1. Now, you don't have to do this part. I just want to show you what it looks like. How many more zeros are on this graph? There are 2 more zeros on this graph. Ms. Markey, how am I supposed to know how to do this stuff? You don't. I'm telling you right now, you don't have to do what this is, but I'm going to show you the easiest Easiest way to continue with this problem. Look, I'm dividing it again. It still has an x-intercept. Here's what you're going to do. I said there were two ways you could do this. Number one, recognize that you have a repeated zero because a turning point occurs on an x-intercept. Or, you know how you guys were telling me you got down to this part and you didn't know where to go next? You said, look, Mr. Mark, I got this. Did you write down the equation or did you write down the numbers? You just wrote down the numbers. Okay. Because I had the numbers here. But you can get that equation if you can write that equation. Remainder, constant, x squared, x cubed. If you can write that equation and then you literally say, where do I go next? This is what you could do next. Negative x cubed minus 1. Put it into your y equals key. Put it into your y equals key. If you graph that sucker, now you know where to go next. Negative 1. Negative 1. Remember, turning point, x-intercept, it repeats. Now, if you don't know that, if you don't remember that, you do have that equation. This is that equation. I just put it in. That's where we're going next. That's where we're going next. Put the equation into your graphing calculator. That's where we're going next. Excitement fills the air. Rolly chair. Zooming out. Negative 1, 0, 0, negative 1. That's where we were at. You can get that additional 0 by looking at that resulting equation. Negative 1, positive 1, 1, negative 1, negative 1, positive 1, 0. It works. Now, this resulting equation is negative x squared plus x minus 1. That resulting equation, negative x squared plus x minus 1. Mr. Markey, I don't know what to do next. Look at the equation. Look at the graph. Type it into your y equals key and look at it, and you will see what you have to do next. I'm going to type that equation into my y equals key. Oh, you're going to hate this. Because it's an x squared. No, that's not why you're going to hate it, though. You are going to hate it. Say again louder. There aren't any x-intercepts. But I did say we had to find all the solutions. The problem is the remaining solutions are not real. They are complex. You can't factor it. You can't continue with synthetic division. You have no choice but to do the quadratic formula. You have to do the quadratic formula now. You have no choice. You can't factor it. You can't continue with synthetic division. You have to do the quadratic formula. Let's do it. B squared minus 4ac is 1 squared minus 4 times negative 1 times negative 1, which gives me, of course, writing this down, a negative 3, which is terrible, but that's what the discriminant is. That's what's going inside of that square root. That is what's going to cause the I to show up. Negative b plus or minus the square root of -3, the whole thing, over 2 times -1 equals. Now, what's interesting about this is on the bottom of the fraction, you're going to have that -2. But that negative is technically dividing both of these terms. But it's not going to affect the plus or minus. So in reality, that negative would just cancel out the negative in front of the b. I'm writing down this answer, and then we're going to talk about what this is in a moment. Circling those as well. On the bottom of the fraction, we got a -2, which technically divides both of these terms. It causes that 1 to be positive. It doesn't change the plus or minus. The plus would become negative, the negative would become plus. So it doesn't change it. But this -1, the one that I am pointing to right now, this -1, the square root of a negative, pops out an I. The square root of a negative is going to pop out that I, and there it is right there. This terrible fraction represents the two complex solutions. It is 1 plus I root 3 over 2 and 1 minus I root 3 over 2. There are your repeated zeros right there. And there's your other 0 right there. This thing only had 2 real solutions, but it had 5 total solutions based on the degree of the polynomial. If you're ever stuck with, well, what 0 do I do next? You need to take the resulting equation, put it into your y equals key, and see what is left to divide out of the problem. Once you get it down to a quadratic, that is when you have multiple options of synthetic, factoring, or in our case, the quad formula. I am going to be assigning that major assessment this week in regards to the entire chapter. Please make sure that you are aware of it and pay attention to the due date when it is up there. You will have plenty of time to get it done, of course. But it is going to be a major, so it's going to be a little more extensive. I'm excited. I know about you. Oh, he's saying hello in the chat. Hello. Anyway, if you have any questions, make sure you're emailing me. Bell's going to ring. I'm going to sign off. Click, click.